Test, test. Asi hej.
Hello everyone. Let me welcome you here on next talk. This is Matus Kocka, and he's gonna tell us what lessons they've learned by using OpenStack in GoodData.
So, hello, I'm Matus Kocka, and I used to work in Red Hat for 6 years. Now I'm working in GoodData here in Brno, and in next, 15 minutes, I'm going to tell you some information about how we are using OpenStack, what is important for us in OpenStack, and also some information about our company. GoodData is a small company from Brno which grow out to all around the world, and GoodData is doing something which is called business intelligence. And basically the goal is to somehow help companies to do their business decisions over their data. So basically lots of companies have lots of data and they don't know what to do with the data. So they using Excel, they're using, I don't know, something from Google, and then they're making some decision. Well, GoodData is providing kind of platform, we call it platform, to customers, and they can give us their data, and they can prepare dashboards, they can prepare reports, they can prepare everywhere what they need to make their business decisions. So for this, we are using kind of platform as a service, very high performance platform. And looking at our other companies, well, in this kind of sector, there are lots of companies which are huge, like Oracle, Microsoft, Google. So it's very nice to see small company, something about 400, maybe 500 employees in this kind of field, fighting with Oracle, fighting with Microsoft, fighting with Amazon Web Services, which are super huge companies. So that's something which is really nice. And what we are doing, we are doing things like this. Basically, when you are a company, you have lots of data, you want to have some fancy dashboard, you want to do something for your customers, so you can use our tools to provide some graphs, to provide some reports to your customers, or just to use these reports for your own business and have some basically reports. And this can look very, very differently. For example, something like this. You can have, some very nice plots, very nice dashboard, which comes out from our platform, which is using your data, our customers' data. And the nice thing is that this is basically doing on the fly. So that's one of the most important things that we are trying to, we are actually doing it. We are producing these reports on the fly in real time, which can be sometimes tricky when you have big amount of data to do some reports on the fly. For example, we can do something like this. This is some kind of graph which is making report about how some stores grown and died in United States. So these are the products which we are creating and how we are doing that. Well, we are using Rackspace as a managed colocation, and basically we have lots of compute nodes in data centers. We have 3 data centers, 2 in North America, 1 in Europe. Our biggest data center is quite large. It's more than 500 compute nodes, and these are pretty powerful compute nodes. Basically, it's 2 NUMA servers, which lots of memory, lots of cores, because we need to proceed big amount of data in databases. And we also have lots of storage. We have about 20 terabytes storage per compute node. So you can imagine that we have lots of data. And why we are that's actually one of the first question you can imagine, why we are using managed collocations and hardware, why we are not using Amazon. Well, basically this is the most cost-effective way. If you can probably very easy imagine that using this kind of amount computers or instances in Amazon it will be very, very expensive. And we also have a two years hardware cycle, and we have basically our own cloud from OpenStack, so we have our own rules. And these 2 years hardware life cycle is quite important. For example, the previous talk about the redfish, well, that's one of the things which we want to implement as soon as possible, and it's a very new thing. So to have a new hardware every 2 years, that's help us do these kind of things. And we want to do it because we providing our solution to customers like all the time. We are trying not to have any downtimes. We are trying to be available all the time. And that's a little bit tricky, even with Amazon. So we are using lots of open source software. So basically, if we can use open source software, we are using that. So we are using CentOS, we are using OpenStack, we are using PostgreSQL, we are using MariaDB, we are using even Grafana for the monitoring. And what we are doing with the OpenStack? Well, OpenStack is the tool which is providing all the basement, basically private cloud for our services. So we need to have asynchronous creation of the resources. And it's a little bit different than maybe you are used to, that you are creating a virtual machine, then you are killing the virtual machines and doing stuff like that. No, we need to have our virtual machines to be very high available, so our virtual machines live long time, and we are basically using quite a powerful hardware and also big instances to do lots of computing. How it looks like internally in OpenStack? Well, we have a lot of tenants, production tenant, internal tenant. We have tenant for the testing. We have tenant for CI, and OpenStack is a very huge package, but actually we are using only a smart part of tools from OpenStack, but we are using that quite massively. So we have a very, very huge infrastructure, so that maybe can be important for OpenStack developers. That many times you heard that somebody is using OpenStack and he has something like 20 compute nodes, 100 virtual machines, stuff like that. Well, we have many times more. What I want to tell you actually is what we learn from the OpenStack and from the basically using this. The most important thing for us is always optimize it as much as possible. We want to have the optimized kernel, optimize virtual machines, and that's sometimes very, very hard. If you imagine that if you have a lot of patches, if you have a lot of optimization, custom things, then it is very hard to maintain. If you have something out of box, it's usually not very good performing. And so we are trying to have a balance between these. So basically there are two things which are important. One is NUMA, and to have a good instances to NUMA. I will show you some picture then. And also to have a good I/O stack. Don't have lots of IOAs, don't have lots of problem with I/O. So one very easily exercises, if you have let's say 200 hosts and you have a performance penalty because you don't have a good tuning, you have a performance penalty 10%. Easily you can calculate that over 2 years you will have something about almost $500,000 cost for that you have only 10% penalty. So that's the reason why we really want to have everything tuned up. And well, this maybe sounds not much, but that's this kind of car per 2 years. So yeah, it maybe looks funny in a light with all the Intel problems, because that will be similar 10%. So probably Intel have your Ferrari somewhere, but but yes, this is very important, and this is important because our compute machines are working during whole 2 years, almost full load. If you have 48 cores, we have loads about 47, 46. So, and back to the some important tuning. Well, one of the most important thing in modern computer world is NUMA, because, well, I guess mostly of you, if you have some kind of servers, you are using 2 or maybe 4 NUMA machines. If you have a big infrastructure, you very soon figure out that 2 CPUs, 2 U servers are the most cost-effective, and then you have 2 CPU sockets, then you have something about 40, 60, 70 cores, but you have that problem that if you are just running one operating system and you're running some applications, the kernel with its NUMA scheduling can easily schedule your applications and everything to one NUMA domain and another thing to another NUMA domain, and the application will touch only to the memory which is local to that NUMA domain. But that works very nice in a bare metal world, but that don't work that nice in a virtualization world. So if you turn off your NUMA, then basically your virtual machines can go here and also can go here, and then you will have the problem with this bridge. So what we learn is very, very important to always have instances which are only in one NUMA domain. And this is even more important if you are that kind of person which are not using Intel hardware. I personally don't know many companies who are using AMD. Is there actually anyone who has some AMD CPUs on a server? Really? And you know that in AMD you have even more NUMAs. You have, I think, 3 per socket now, or 4. So it's even more important to actually have this kind of alignment. And we also know that if you have virtual machines which are dedicated to very hard computing, it's important to have no overcommit at all. Basically, have to pin it to the right number of the cores. Don't use more virtual cores, because that it will have a very, very huge computational penalties. Of course, if you have virtual machines which are basically doing nothing, just waiting until something is happen, then you can have some overcommits, but stay very low and don't do some huge overcommits. Basically, other thing which is important is I/O. What we are doing is very, very I/O intensive process, because we have databases, we have a huge storage, and we have several virtual machines on one compute node. And this is very, very nice picture about Linux storage stack. And there is a very important thing, and that's a block multi-queue. That's the thing which you definitely want to use. And that's because if you don't use that, you will have a very, very lots I/O weights, and probably your virtual machines will have a big problem to store or read your data to your storage. Even if the storage is much faster than you're expecting, you will have a problem. And we have a kind of smart setup for this. Basically, we don't want any complicated I/O schedulers. Once I had a presentation about I/O scheduler here on DevConf, and you probably know that there is actually in Linux kernel there are 3 I/O schedulers. Noob and Deadline are quite fast and a little bit simple. Completely fair scheduler is more for rotational drives. So what we are doing is that we have no scheduling, or the basic one on the virtual machines and on the guests. On the host, on the guests, we have a block multi-queue, and then we have the best RAID controller you can buy for normal money, which is usually the best one, which provides the vendor. And then the controller is doing all the magic. And because the controller usually has some kind of cache, it's usually several gigabytes, it's the fastest setup. And we really know that if we don't have this in this setup, which is actually very easy to set up, the performance penalty can be even several times. So it can be even 2 times faster than you have set up that correctly. So now we even thinking about to have the same number of RAID controllers than the number of NUMA domains. So then the one CPU, the one socket with one NUMA domain will have its own controller. So even this, we want to speed the things up. Yeah, basically, I think that's everything what I want to tell you. And also we are hiring like all the companies, I guess, in Brno. And this is a picture from our nice offices. So if you are interested and you know how to DevOps or how to code something in Perl or Ruby or whatever computer language you know, just Google us. And if you have any questions, yes?
Are you using self-storage as backend?
No, we don't yet. We won't. That's the thing. Currently we are not using any object storage, but we are thinking about use some, but we don't have that implemented yet. So we are currently thinking about SEP, but we actually used to use a SEP before, but not now.
And what storage do you use now?
Well, basically we are using the storage of the it's block device, the local block device. We are not using the network storage or any object storage because we had the problem that it was not fast enough.
So for aggregations and the calculations, you are not using something like Elasticsearch and so on?
No.
Or the data. So what was the storage you are using, which has better performance?
Well, it's because we don't. Well, I don't know. Actually, it's not my field what I'm doing there. So maybe I'm not 100% correct. But we are using basically one big file system on the local drives, which is connected through CIDR. But that's a local storage. And we have in OpenStack you have the availability zones. So we have it kind of tuned that one compute node is one availability zone because our virtual machine is long time. It's okay. Huh?
Do you upstream your enhancements?
Well, no, but I think we are sometimes putting something on our block. Well, these enhancements are basically the well-known things. We don't have much our own code. I think 2 patches maybe already. Yes.
Just for like the reference to Open is like Cell V2. It's like everyone's patching in a lot of stuff, and now they agreed to put it upstream and makes it much easier for everyone. So it's like everyone has similar kind of needs. It would be better if more people work upstream, like Red Hat usually do, for example.
Yeah, I think definitely want to do it.
So if you don't overcommit, why don't you go bare metal? Because then you don't need to optimize, like put so much optimizations into the guests. I mean, I guess also the workloads are quite similar.
Yes,
so
but it is. But true is that with this kind of virtualization layer, you have a little bit more control for each VM. We have a small number of VMs, but we have usually 4, 6, 8. So if you do this only on a bare metal and you have some problem with the kernel, basically whole node is down. So that's the reason. Yeah, so the penalty is actually not that big to have this kind of opportunity.
So you say that you change your hardware every 2 years?
Yes.
So
Yes.
what do you do with old hardware?
Well, we are using the rack space. So basically you have deals, that's usually 2 years or something about 2 years, and you have the renewals. So it's rack space hardware, it's rented. Well, it's much more cheaper when you calculate it to actually have your own data center. Yes?
Sorry, are you using an OpenStack distro, or are you using OpenStack from upstream?
We are using upstream OpenStack.
From master?
That actually, I'm not sure. Yes, probably yes.
Okay.
And we are usually not using the newest, so we are now want to migrate to Pike, but we are not there yet. It's because it's not that easy to actually do the migration. Okay. So, yes?
Which installer do you use for OpenStack?
Which versions?
Installer. Which installer? Kocka or Kocka Ansible or something else?
Director.
Well,
Do you have Ansible for Insight? And
yeah. No, as far as I know, we are not using Ansible, I think, anywhere. Mostly we are using Puppet. Okay, that's it.
Sure.